All right. I am hoping this works. The entire setup's a bit interesting because I'm doing this through Zoom and then live streaming it to LinkedIn. So if you wanted to participate more aggressively, you could join the Zoom meeting and there's a link on there. Otherwise, drop comments on the LinkedIn stream and I'll follow up there. Okay, and I'm sure over time I'll evolve this as this goes based on sort of what I like, what I dislike. Cool. That's a bit weird speaking to the void, but thank you all for being here and welcome to the inaugural Dan's Data Ops hours. This is the first one, and I'm still figuring out the best way to manage. So expect the format to evolve. But my goal here is to make it as interactive as possible and try to help and share my knowledge with as many people as possible, and specifically in data, but honestly, all sorts of engineering or people leadership and bringing things on the table. And if you have any ideas or ways to run this better, please let me know. This is the first one. And shout out to Jeff Skoleberg, Brian Correa, who helped me get this thing set up and even inspired me to do this. So this particular session is being run via Zoom and then live stream to LinkedIn. So you can join on either one. Zoom is a lower latency. So if you want it to be more interactive, and throw comments on there, I think that would be easier to have like a real back and forth versus LinkedIn, I think ends up being maybe like 20, 30 seconds delayed in my testing. So I'll get to it, but the flow might be a little bit wonky. So a quick intro about me. So I'm Dan, the founder of Twing Data, and our goal is to help companies reduce cost and improve performance of their data warehouse by analyzing their actual workflows. Before this, I spent 10 years at TripleLift and at that company in a variety of roles, where I started as an engineer and then ended up somehow leading the engineering team. We ran a pretty massive data operation and had multiple iterations of the data stack, which is sort of where I fell in love with a ton of the data processing in the modern data stack. So I want to use this time to help others by sharing what I've learned, both during my time at TripleLift as well as growing Twing Data. And I also hope to learn a ton from everyone here. So please, please, please participate, ask me any questions, and I'm glad to return the favor. So to start, Jason, who I used to work with at TripleLift, was kind enough to drop some questions on LinkedIn, like in the LinkedIn comments, and now I'm going to run through those. And as I mentioned before, I want this to be interactive, so please participate and let me have it. Cool. So the first question was from Jason, and it was, if you had to break down the waves, in quotes, of data engineering technologies, what would that look like? So I'm a big fan of this question just because it's like so ambitious, right? It's how do we summarize, multiple decades of history in a very quick sort of live stream conversation? And it's nice that he sent it ahead of time so I don't have to improvise too much. But my experience, and I'll start this one somewhat recently, about 20 years ago when I started my career, right? I started my career in the early 2000s, and that's, well, I have a much better appreciation for it. So in my mind, the V1 of like data engineering, it was there's no such thing as data on its own, right? Data ends up being a function of the rest of the business, and companies would typically have a database and what we could think of as online transactions, right? If you're running an e-commerce site, you would have a database that would have orders, it would have user activity, number of products, and so forth. And a lot of the analytics at that point in time was really around supporting the business. You just didn't really have the scale or the complexity of the data to do anything beyond that. At the same time, and this goes back to my sort of reminds me of my first job. My first job was working as sort of like a data analyst at a company called ZS Associates that did consulting for the pharmaceutical industry. And what we would do is we would get these tapes, so physical tapes with gigabytes at that time. It was pretty big data, with gigabytes of pharmaceutical prescription orders. We would load them in to a tape drive, hope nothing failed during the load, and then would run these pretty large statistical jobs written in this software programming language called SAS, in order to then dump the data into Excel, where we would then manipulate it, create the pretty charts, pretty pivot tables, and put it into PowerPoint, which we then use to share with our customers, right? So even back then, or as is now, sort of the entire world revolves around Excel. So like that was the flow, right? It was like very I would say like maybe the way I would think about it is like data did exist at large scales, but it was like very batch heavy, right? And very high latency, where you didn't really have this idea of what we have now, where you could like suddenly capture gigabytes of data and immediately make it accessible. Like back then, there was a lot of overhead to even like analyze and process the data. I would say like that's sort of like the V1 in my world, right? Excel was king, and everything was really happening on this single node. I think probably the biggest, in my mind, the biggest innovation after that was that the data became distributed. And you could think of it as coming along with a cloud, right? The first time Amazon, released their first set of products, I think it was like EC2 and S3, like that completely changed the game for startups, for anyone really writing software. Before then, you would have to go in, and buy your own hardware, go to a data center, like figure out, how to rack the servers, deal with all that. Like as soon as AWS, went public, like you did not have to do that. You can start a website immediately and pay as you go, right? So it's completely game changing. And as part of that, it also became possible to start saving sort of files on S3 without really worrying about hard disk space. And it was incredibly cheap. So what happened is every company, just starts saying, you know what? We have this data, let's just save it to S3. We may not need it right now, but maybe we'll use it a year from now, 2 years from 3 years from now, but it's so cheap anyway, let's just dump it in. And as soon as that happened, there became this need for, well, now that we have all this data, how do we actually analyze it? How do we process it? And that's when this distributed sort of compute platform, think something like a Hadoop, MapReduce, sort of came out to be, right? It's this idea that you could parallelize your computation by creating a ton of different, basically taking your data, splitting it into a ton of different sort of chunks, and then having each chunk processed independently, and then the result being combined into one in like a much more sort of optimized aggregated form. So that's like, in my mind, like this phase two, right? So led by the cloud providers, this idea of like distributed data. Probably the next big evolution in my mind was really these data warehouses that said, we're going to be designed purely for analytics. So, how the first phase in my mind was this idea of like transactions, right? Powering your business. Now there's this whole paradigm of, hey, let's design databases in order to support analytics. And that's where you see the rise of something like Vertica, like Redshift, like these larger sort of traditional, basically what you call like a data warehouse, right? In that case. But the key thing there is the data itself was still linked to the compute. So very similar to the old world. If you, let's say, had, I don't know, 1 terabyte of data, you needed to have like a database that had at least 1 terabyte of disk space, right? Or memory in order to store it and in order to analyze it. So if you ever had too much data going on, what you do is you would have to resize your database, make it bigger and bigger and bigger in order to handle both the size of the data you needed, but also the types of computations you performed. And while these sort of OLAP, these online analytic processing databases were designed for like fast analytics, you were still at the mercy of sort of like the data volumes. Big iteration after that, and sort of this is where we're getting into, I would say, more of this like modern approach. And I imagine like someone like a Snowflake and Databricks to an extent pioneered it, or at least made it mainstream. But it's this idea that, hey, you could actually separate the storage from the compute. So you could store all your data on S3, which we spoke about before is incredibly cheap, but you don't have to do anything, like you don't have to have a database that's up and running 24 hours a day to take advantage of it. Instead, what you do is, if you want to run an analysis, spin up a small cluster on Snowflake. It will fetch the data from S3. It'll run the analysis, run the query, give you the results you want, and then immediately shut back down, right, to sort of go dormant until you need it the next time. And that was huge, right? I even remember like when we were at Triplets, like that was really a transition that mirrored for us, right? Initially, we kept everything in MySQL database. Then we said, hey, let's actually start processing it in Redshift. At that point, it got too expensive, and then we introduced Spark and Databricks in order to still process the data there. And a couple of years later, we introduced Snowflake. So even our journey at Triplets sort of pioneered or mirrored rather the journey of the overall sort of like data, these data waves. So now. So I think go ahead and ask like what's actually happening right now. And actually, very related question. But a couple of days ago, I was browsing LinkedIn, and there's a VC at 3D Ventures, Tamash Tangus, and he wrote a pretty good post, which is this idea of unbundling of storage and compute, right? So the previous version was the separation of storage and compute, where Snowflake, would internally have storage, and they would charge you, one amount for storage, and then when you needed to compute separately for it. But now there's this movement, and I think there's still to be said, how dominant is it going to win? Is it going to play? Is it, really going to sort of stand out? But this idea that you don't need Snowflake to store your data on Snowflake either. You could store the data outside of Snowflake on something like S3, and then use Snowflake to pull it in to do the compute, and then put the results back onto S3. So at some level, you're saying we don't really need to be locked into a vendor at all for both the storage and compute layer, but instead they could be, we could be using completely different products for each of those. Related to this idea is like Cloudflare, right? They're a CDN, start as a CDN, but they also have an alternative to S3 called R2, and they're pitching that, hey, it's going to be a lot cheaper for you to store data on us. We're not going to charge you for egress, which is really a big chunk of how Amazon makes their money with S3. And it sort of enables a whole set of use cases. Like you could imagine saying, I'm going to store my data in the cheapest possible location, or whether it's cost or whether performance, whatever you care about. And then you could use a completely different way to access the data, compute over the data. So like a lot of people are pretty bullish on this idea, right? Keeping the data neutral, but then applying different ways of computing it. Something else related to it, and I don't know how many people have heard, but a big, like something that's coming up these days is DuckDB. And their big pitch is, what if you create sort of like a Snowflake-like database that runs on a single node? So it's not distributed at all, but given how large computers are right now and how much RAM, and memory they have, what happens if you just create an online sort of this like OLAP database designed for a single machine? And what can you do with it? And it's interesting, right? They had a pretty good post a couple of I would say like last year that basically says, you actually don't need big data. Most of the time when companies talk about big data, they don't really have big data. Instead, load it to DuckDB, run your analysis, and you don't need to worry about the cloud or any of these vendors at all. And I think there's something interesting there, especially if you could combine the two approaches. Like you could imagine, and I met someone who's actually working on a pretty cool idea, Dan Forsberg, working on this company called Boiling Data. And they're saying, what if we could take DuckDB, put it into Amazon Lambda, right, their serverless technology, and then run really like this like map reduce job completely outside of these larger data or like traditional data warehouse. So there's like a lot of interesting things happening. The other probably interesting thing happening beyond all of that, and we haven't really talked to, is AI and like what's that going to do? Like everyone clearly wants to take advantage of it. Of course, like how? Like will it be? It's like like there's quite a lot of solutions, at least around trying to include AI in this BI world, right, in the human interface. Like maybe there's like the dream for everyone is this completely natural language way of being able to to query your data and say, simple questions would be, how much was my revenue last year compared to this year? And then, more difficult question would be like, well, explain why there was a drop, right? And it would say maybe it would slice it automatically across different dimensions, come up with some hypotheses, and give you sort of some I think explanation. Maybe beyond that, you could say, well, what can I do to address it, right? And you could imagine that's the dream, right? If you have this data, you really could think of these AI tools as getting you closer and closer to be able to sort of surface these insights and help you answer some of these questions. And I think that's still obviously very early, like this role of AI, and we're gonna have to see how it all plays out. So that's first question. Let's see the next one. So next one, another one from Jason. What's a skill that's underrated in this domain? So, or you phrase it, or you can be the best technically, but ... So I spent a little bit of time thinking about this as part of this preparation. And as with most, as with almost all things, like the really important thing for everyone really to understand in any role is the business, right? The business context. Like, how does the business make money? Like, what is your role in help making that happen? When it comes to data, data also tends to be on the receiving end, meaning that in a lot of companies, you may have let's say, an engineering team that's writing to support an application. Maybe it's like an API or like a UI, and they're collecting data throughout. Then that data makes its way to a database, and then makes it to another database and another database. Maybe you have some real-time streaming somewhere in the loop, and at some point it makes it to a database that's finally accessible by the data team. And at that point, the data team needs to take that data, translate it, and process and transform it in order to make it useful for the types of questions that they want to be asked, right? Generally shifting this idea from transactions, right, supporting the business, to analytics, being able to ask questions about the business. And it's at that point where I imagine, like, I've seen a lot of information get lost, where the teams, like, just because they weren't in that initial conversation, they're reacting to the data as if they've sort of seen it for the first time. So how could you, if you're like on the data team, move your way, further upstream to the stack to understand, like, how's the data generated, right? Why is it being generated that way? What's triggering the events? What do the different values mean? I think by understanding that, you end up being incredibly more valuable, like, to the company, and you're going to be able to really, like, sort of be much more autonomous and understand exactly what you're being, asked to do, hired to do. I'm gonna do a quick check on LinkedIn to see if there's any comments on there. Cool. Okay. No comments on LinkedIn yet, or no questions, I should say. Okay, so next question that I got, also from Jason. So what is in your data cost optimization tool set? This is probably a leading question because I'm trying to focus on cost optimization on Twing, but without looking at Twing at all. And it really goes back to this idea of like understanding the flows in the tools, right? In order for you to understand, where, what are you gonna, how are you gonna optimize your data costs? You want to understand like the overall flow of the data and the tools you're using. So if you're using, let's say, Redshift, like you want to know what is your Redshift bill, but also how does it compare to everything else? Like what are the inputs to it? What are the outputs? Like if Redshift is, let's say, 1% of your bill, but then the rest of, if it's 1% of your total AWS bill, the question might be like, does it make sense to focus on Redshift at all? Right? Maybe there's something we could look that's outside of the data that's going to have a much bigger impact than focusing on the data piece itself. But if we're focusing on the data piece, or really anything infrastructure, seeing it all in a single place is very important, right? You want to be able to put everything, whether it's an Excel spreadsheet or some sort of tool, just to be able to see and attribute the costs to the different services, right? Are my costs coming from, EC2 running the compute servers? Are the costs running from a data warehouse? Are the costs running from data transfer? And that was a big part for a lot of ad tech companies, is that the data transfer sort of kills you. Amazon makes it free for you to sort of get data coming in, like data ingress, but they charge you quite a lot for data egress, so data coming out. So it's like these sorts of things are going to be very dependent on your business. And once again, you want to understand how does your business work and what are the biggest cost drivers in order to then sort of dig in at a deeper level. Once you understand the like higher level costs across the different services and systems, that's when you want to take a deeper look and understand and basically this idea of tagging. So you want to tag everything as much as you can, as often as you can, right? You really should not be like, no one should be able to, you should not be able to have a dollar or a penny that's unexplained, right? Instead, you want to be able to say, this $3 were spent on this job on this day running at this time. And it was run by this person or by this system. And if you could do that at scale, and then it becomes very easy for you to go in and do various slices and dices and filters to really understand your cost structure. So maybe like a very concrete data pipeline example would be, let's say, and this goes back to a similar approach to what we had at TripleLift, is let's say you have a pipeline that's pulling data from S3, then loading into Spark and running different sorts of jobs. Some jobs run hourly, some jobs run daily, some jobs run monthly. And what you'd be able to do is you would say, no, out of all these jobs, let's say group by the job type or like job name. And you say, oh, the amount of, the cost of the daily jobs, and there were 24, or sorry, the hourly jobs, and there were 24 per day, was, let's say, $1,000. The cost of the daily job was $100. Like, what does that mean? Like, that probably means you should focus on the hourly jobs because all in, they're going to be much more expensive in the aggregate than optimizing the daily. So it's like these sorts of things that you can look into. Later on, what you also discover is a lot of the data workloads, there's going to be the schedule component, right? These jobs that run on a schedule, every hour, every day, every month, what have you. But the other big element is going to be interactive usages, right? Let's say a data engineer doing an investigation, or even like developing a new pipeline or a new job, or a data scientist trying to understand what are they going to, like how could we model and do some sort of prediction, some sort of calculation. Other than that, you might have, someone like a sales rep trying to understand how are they doing given their quota. And that, in that case, they're accessing that data through a BI tool such as, Looker or Metabase Tableau. So in all these things, you want to be able to sort of tag the cost, right? Being able to associate the cost typically to the job type, like what is the job that's causing it? What is the environment? Is it testing? Is it development? Is it production? And ideally, like who owns it, right? What caused the trigger? And if you have that across every single one of your systems, it becomes pretty easy to sort of start digging in. Once you dig in, there's a whole other category of, how do you actually reduce the cost? And I think that's going to vary, right? Some of it's just simply going in and saying, we're doing inefficient things, maybe, and there's quite a lot. So for example, like if you're using Snowflake, one of the settings could be default timeout, meaning like if my database has not been used for 5 minutes, shut it down right away. Like these sorts of settings. Other ones are going to be much more around the data, bad queries. You could look into a query and say, hey, this query is like in order to answer, let's say this, business request, the query only needs to look at 1 day of worth of data, but whoever wrote it, it needs to look at 3 months worth of history. Right. So what do? You change it to only look at the most recent day. It's like these sorts of things do come by analyzing the query at a deeper level, but you could only do that if you know where to look in the first place. So I would say like 80% of the problem is knowing where to look, and then the 20% is actually doing the work to tweak it and optimize it, and even if it is optimizable. Let's go to the next question. Let me check LinkedIn super quick. Cool. So next question. Are there any industry sectors that are not deploying data effectively? Is data still the new not commoditized oil anywhere? So thank you, Jason, for the question. So it's an interesting question. Like, and I don't have a good way to answer it. My gut is everyone these days realizes that there's value in the data they have. And it's really a question of like, how do you surface it and how do you make it actual and useful? AI is for sure accelerating it, right? And a ton of people are making the point that, garbage in, garbage out. So if you could invest in cleaning your data and, make polishing it up and making it accessible in some way, then you're going to be able to take full advantage of the AI tools. And I believe there's some truth to it, but I think data, end of the day, is a tool just like everything else. And for you to take full advantage of the data that you have, you want to really understand, once again, like it's really at the service of the rest of the business, right? And to do that, you really need to focus on the business itself, right? What is your business strategy? Is your team able to execute on the business strategy? Do you even have the right strategy? So data has a hand everywhere, right? For you to make these decisions to help the business forward. But I don't think data on its own is really gonna, like help suddenly, make you successful or not successful. Right? It helps and it's a tool, but it's really about the surrounding context and how it's used. And I do think there's quite a lot of tools, once again, that are trying to make the data accessible, right? Self-serve analytics. And I was in a previous, like another live stream earlier today with like Jeff Skolberg, where he was chatting about like what is self-serve analytics and is that a real thing? One of the points there is when you do any sort of data request, you want to understand, let's say you get this bit of information or you get your question answered. What are you going to do with it? Like what sort of decision is going to make you or is it going to help you make? And then if you do that, what are you going to do next with that bit of information? What about that? What about next? What about next? And if you keep asking these, what questions, why questions, like that's how you really understand like the point of the data you have. Which is also, I think, why a lot of people are trying, sort of sick of dashboarding, right? They're like, we have too many dashboards. We created one 3 months ago. No one ever looks at it again. And it's probably this idea that people are looking at data for the ultimate solution, but instead, like they really should be thinking of like data as a tool, right? To like help them influence others. Like the best I imagine, like the way I've seen the data sort of work best is when it's sort of change your business strategy or changing your operations. Not something that you simply look at, say, hey, pretty charts, pretty pictures, and then move on, right? You want it to both give you a sense of how you're doing as a business and also help you change course, like if necessary. Let's see. Anyone have any more questions? No questions. So let's see. I could come up with my own. Maybe I'll go in and talk a bit about, let's see. See, I should have prepared. Yeah, I'll talk about maybe like something else I've seen. Um, and maybe this question of like AI in BI tools. And how do I think about it? What do I think about it? So I love the idea, right? This idea of being able to ask, this like magical system, like any sort of question that's rooted in understanding the data, like is incredibly powerful. Like going back to my previous example, imagine being able to ask your sort of data, why did I make less money last quarter than the previous quarter? And it goes back and says, well, it's because, in this region, like something must have, in this region, there was fewer sales. And then you go in, well, why were there fewer sales? And so, hey, there was a weather event that, I don't know, caused shipping delays. Like imagine being able to get that sort of like very clear, crisp answers from your data system, your BI system. Because like how far away are we from it and how are different companies handling it? So I've seen like high level, like three different approaches of how companies are thinking of sort of incorporating AI in their tools. So one form is you really trust AI to do everything, right? You basically say the AI is going to generate the SQL query on its own, and it's going to execute it, and it's going to give me an answer. And I'm generally bearish on that. Like I think I've seen some pretty bad queries in my life, and there's so much nuance to how companies sort of like think about their data and model their data and like define their metrics. And it's not very useful when you as a human can't verify the accuracy of the results. Like AI is great when in like a chat interface, when you as a human could sort of see that the results you get are real. Like imagine like rebooking a flight. I have a conversation with United and whether, someone in United, whether it's a human or an AI sort of chatbot, and it tells me the end result is, you have a flight out of Newark at 4 p.m. in 2 weeks. Like that's great. Like as a human say, yep, that's great. I got what I wanted. I didn't really care how I got to me. But if I'm asking, what was my revenue last year, and it tells me 13.9 million, when in fact the real number was 13.4, like as a human, just don't have that idea. So how am I ever going to trust it? The other, I would say, like a step above that, are I've seen some companies taking this idea of like modeling what they call like the semantic layer, meaning like how do we define the metrics? How do we calculate churn as a business? How do we calculate revenue? How do we calculate retention? And those are defined as code, and then the AI systems are writing the queries around it. So the metric, the definition is always the same, but the surrounding context. So then is generated by an AI system, right? Like an LLM. In that case, that's it. As you can say, when you calculate revenue, you look at this table, this is the field, you filter this out, you subtract this, you add that, and like that's in code. But the query, when someone says, compare it year over year or give it to me by region, like that's all going to be generated by like AI. And then the last one is AI generates the queries, but then a human has to sign off on it. And there's some clever approaches where they try to calculate the confidence score. I'm gonna be 90% confident that this query is right. And you can have a rule that says, if the system thinks it's 90% confident, just execute it. And then it sort of falls back to that idea of like the first one where pure AI. And I don't know, like I worry, like I don't like the third one too much either, because I suspect what happens is like no one wants to like review SQL code written by some, bot. Like at that point, you might as well just write it yourself. And so I'm a bullish, at least for now, on the second approach, where you're taking the hard parts that are unique and novel and specific to each business, defining those as code, and then using a lot of these AI solutions around it to sort of manipulate and structure it and sort of use it among other queries. Let's see. I think I saw some beeps. There might be more messages. No, no more messages. Cool. So right on time. So Jason, special thanks for seeding me some questions. I'll figure out the cadence. I'll probably do this every 2 weeks to start, and I'm gonna work on a variety of different approaches, sort of technology-wise, just to make, once again, it as interactive, as interesting as possible. If you have questions you want me to cover next time, like async, feel free to email me, message me, whatever, and I'll both, and let me know if you want to be anonymous or not, and I'll do my best to answer them when I can. Okay, thank you, everyone.